alibaba.com. Good morning, everyone. I'd like to start to introduce the data architect of the remote or offsite active. So my name is Dachao, and I'm currently responsible for the development of the remote or offsite active development. And DBS is also within our responsibilities. So today we could say that we can have a very extensive research and development in this area. And now let's start. So there are 4 parts of my presentation. The first one is a brief introduction of why do we need to develop this product. That is the background of the development. The second part is the architecture of Ali's product, and the third one is the challenges we have faced. The fourth is application cases introduction, and I hope that through my presentation you can gain some useful information. And let's start from the first one, that is the background, and what are the issues faced by Ali Cloud. We have faced this issue many years ago, and what was the background back then? On the left-hand side, you could see a screenshot of microblog, and it was a very old screenshot because this information was released very early on. So in Hangzhou, in summer, it is very hot, and there is a limitation of electricity consumption. So maybe some of the computer rooms can also have limited access to the power, and we need to compromise for the public power usage. So the major computer rooms of Ali back then were in Hangzhou, and if there is a power limitation in Hangzhou and we could not use the power in the computer rooms, then it will be problematic. Now we need to make a decision whether we need to move those computer rooms out of Hangzhou. So it will give us a question, that is, we need to have a remote operation or synchronization of the data. So in the face of such a series of problems, we want to have such a project of developing the remote active systems. So there are several phases of this project, and apart from the factor of a power limitation, we also have some of the other objective reasons. So maybe in the colder days, we do not face the problem of a power limitation. And for some of the other objective issues, for example, the computer is shut down because of the other objective reasons, and sometimes the optic cable was digged out. And according to a report, well, this report was about a fact several years ago, but it still tells us some phenomenon. Our computer rooms would face all types of the problems, and how can we solve those problems? And the previous speaker also introduced you the level we have reached in the disaster backup and the disaster standby. So if we want to have a real-time synchronization, we would need this kind of DTS system. So I'd like to introduce the functions and capabilities of DTS. Generally speaking, there are 4 major functions of DTS, and the major purpose of using this product is to transmit the data. As long as it is related to the data transmission, then the flow of the data related to big data should be managed by DTS. We need to drive the flow of the data. So it was inherently growing in Ali, and we have a very strong demand for consistency of the data. And at the very beginning, Mr. Zhang Rui had also talked about our highlights on consistency and the safety of the data. And it is a highlight, but it is also a fundamental requirement. Well, if we want to do that, it's very difficult. We want to guarantee the consistency of the data. That is to say that the data had been transferred in this product and must be correct. So how can we make sure that it's correct? Later on, I will spend more time to illustrate that. So the second problem is homogeneous and heterogeneous databases. We have a lot of corporate databases, for example, AliS, an Oracle database back then, and we also have a PG, many different databases, including HBase. So there will be some data flows between those databases. We will have the DBA from the databases, and we will also have a little bit big data assets. So the third and the fourth is about the standard. You want a very high performance and high availability of the product. All of these are about the standards or standardization. And we have provided the first capability of data migration. We could help Ali to realize a lot of data migrations. The second one is the synchronization of the data. Some of you may not know the differences between migration and synchronization. Migration is a short-term data transmission, and you could transfer the data from a source database to a target database. But synchronization is a consistent, continuous process. And the third function is data subscription, because in the target end, which was synchronized, we have limited categories and types, but some of the clients want to put the data subscription into their in-house databases or in-house big data systems. So in those cases, we currently cannot support it. So if we cannot support it, the clients can gain the increment through the subscriptions. By gaining those increments, you could realize the function. And we also provide support for file migration, such as SQL and CSV. We not only support Ant Financial and Ali Group, we also support all types of the database on the cloud, and we also support the databases on ECS and IDC. So we would support multiple types of the databases, and later on I will introduce you the challenges we have faced in this process.
After introducing the basic concept, I hope that you can understand how it works. This is the DTS architecture, and we can see what kind of structure it has. And as an user, within Ali, it's the same thing. First, you need to create a task, either on the interface or on API. And the user can assemble that and make it to be automatic. So either from the API and through the interface. And then with the first process cluster, and it will go to a structuring system. And like migration or subscription, it will send to the core functional area. And when you have a task, first you need to have the recheck. They want to know whether you have the authentication to do that. First, you have the pre-check system, and then it goes to the actual work for migration, synchronization, or subscription. And for the online assessment system, it is in a hidden area. If you want to assess whether your library can be migrated to the cloud, and what are the costs, we put it into a not very prominent area, and then it will issue a report. And for subscription, we will provide an SDK, which is in Java version. So you can subscribe the incremental data and write that to the database. So this is about the architecture, so that it can help you to understand how DTS works. After talking about the product, now I'm going to talk about how we developed this product and develops into offsite multiple active. As we have said, we made that step by step. We haven't done it before, so we are also exploring. We're just ahead of the others a few years earlier. We started in 2012. At the beginning, it was off-site cold storage. We make progress every year, and then in 2013, 2014, we have offsites active, and during Singles Day, there was a lot of news saying that we can change the engine on the running airplane. So it seems to be like when our server went down in Hangzhou, we can also rely on the server in Shenzhen. And then we synchronized between China and US, and in 2016. And we are an international company. A lot of our businesses are in Europe, America, Russia, Southeast Asia. So it has cross-border demand for the data, especially between China and US. There's over 10,000 of kilometers, and there are very long latency. So we need to have some technical changes in order to improve our performance and reduce the latency. It will involve some problems here. In 2016, we have a new situation. Internally, including our customers on the cloud, a lot of them are using Oracle or other database types like DB2. And when they're using Alibaba products, they have a request to support heterogeneous active. It's also a big challenge for us because you need to achieve active depth with Oracle and etc. And this year we hope that some of our products, and we have already various, some of the key features can be launched on the cloud. And we can have bi-directional synchronization so that we can achieve offsite active. And we will have more features coming out. So I'm going to talk about details about the offsite multi-active architecture. So the background is that in city A we have a master database, and city B we also have a master database. They want to have read and write in both cities. First, I will build a positive procedure. We will have structured queue and then put it to the dewriter and write to the target. And we also have to ensure some enumerated data. It can be MySQL or Oracle or PG. So we need to have a consistent structure to help us to solve the problem. So it's okay for this direction, but in reverse direction, if we want to write the data in B city to A city, it's the same way. First, how we can do that? Because it's in cycles, then there will be some problems. Actually, there are two ways to solve that problem. First, we have some internal changes. Second, we use the data table to achieve double writing. In that process, the problem is how do you know that the data you're writing are correct? So we have a complete and incremental verification so that we can ensure the data are correct. So during the synchronization, we need to have real-time verification that the data is correct. And we can also check all the records in both databases. And we can also correct them. We also support heterogeneous database. How do you know that between the two databases? Because maybe they have some different parameters. It will lead to many problems. And for offsite, multi-site, we can achieve that. But how do we achieve heterogeneous active-active? So for heterogeneous customers, all of the business are in remote site. How can we switch some of the business to the target location? It needs to go through some process to ensure that there is no problem. And what kind of capability do we provide? We provide an API query capability, and we will tell you what is the latency for this link, and then you can make a judgment whether you can switch some of the service to the other one. And this one is Oracle, or it can also be Ocean-based or MySQL. If the positive synchronization latency is within 1 second, then we can make the judgment that it can allow us to switch, then we will switch it to the other end. And if I switch 70% of to the target, then it's bidirectional synchronization. Many users ultimately, it will take a very long time. Actually, our service is very stable, but we still cannot ensure that there will be no problem with the application. Sometimes the apps will switch from Oracle to MySQL. There will be some cost. In many cases, we often encounter some problems. During the switching, some of the applications were not transferred. A part of that was transferred, so there are still some data keeps writing. So it's different from the expectation for their switching. Maybe originally they want to switch from database A, but actually it became database B. So we need to follow a procedure to strictly check. If we want to switch database A, we need to see for the authentication of the A has been recovered. And for bidirectional way, it will be more complicated because we need to rely on the verification to ensure that there will be no problem. Gradually through that process, by checking the latency, and we can switch the link to B end. So we can complete the transfer, the migration from a heterogeneous and offsite database to the target one. There are some specific things like the structured queue or derider. I didn't go to details about those. First, I want to share with you about what we are doing within Ali, and then I will talk about the technical points. This is our structure of offsite multi-server in early days. Shanghai, Hangzhou, Shenzhen. It's no longer like this now. It's many years ago. So it's a very typical scenario for a lot of our customers. And in the tertiary structure, we provide bidirectional synchronization, like in the business center in Shanghai. And for the data, some of them will be synchronized to Hangzhou, some of them will be synchronized to Shenzhen, but the traffic will be different. Like during Singles Day, maybe the Shanghai center will take about 34%, and the other will take 33% of the traffic. If one unit has a problem, our data again switch back to the center, so it will not impact the business. Basically, we can achieve 2 size 3 centers requirements. This is not the latest data, but the data level is correct. And during single stay, for a transaction database, the daily synchronization volume is distributed in 3 units. On that day, the database synchronization is the PB level, and a peak level at 0 o'clock. The incremental traffic is at Gbps level. And for the downstream of the incremental consumption, because we also provide ground service. Do you remember during Singles Day we had a large screen to show 127 billion RMB transaction amount? Those data also comes from our product. So we have a downstream subscription. You can have real-time calculation to get some results. Some of the figures are for the media, some of them are for our boss. And we have real-time media screen, and we have real-time search backup. All of those things are based on our system. Apart from providing the service within Ali, on Ali Cloud, we also have this problem because it has an international architecture. Through our products, we can also provide some help to Ali Cloud. We can see in multiple centers, we have 11 international sites who are providing the service.
I'd like to briefly talk about the difficulties. We have multiple difficulties, but I'd like to mention two. The first one is the general standardization or normalization module, and the second one is the data consistency. And I think the fundamental issue is to guarantee the consistency of the data. So I'd like to talk about the parallel model, and the case is very simple, but in practice it's very difficult. So we have DBS, and the performance is quite limited, and no matter what you do, there will be bottlenecks. And what we need to do is to have a parallel model. And currently, only Ali can achieve that. That is to say that the routine can be practiced through a parallel structure. And in a lot of the businesses, we have the conflicts, and the relationship between those businesses are extremely complicated. So you need to develop some algorithms to solve those conflicts. I give you a simple example. We have A, B, C, D, and AB is in business 1, and C is in business 2, and D is in business 3. So what are the relationship between those businesses? And I believe that we could first execute the non-conflict businesses in parallel, and A, B, and C are constructed in different structures. So if they are not in conflict, we can very efficiently execute them in parallel. The second one is about the cloud-based issues, and we need to guarantee that all of those data can have a resumed transmission in the breakpoints. And if there is a failure of the machine, and if there is a failure of certain parts of the cloud, then we can make sure that the data can continue to be transmitted between the breakpoints. You can reflect about a lot of issues. For example, in the full migration, and when you have identified the interrupted data transmission, how can you resume it? And in the incremental process, And can you make sure that the database is exactly the same? There are a lot of things to think about. And I like to also introduce about the major module, that is the structuralized storage queues. So what kind of capabilities can we provide through the structuralized module? That is the synchronization between databases. So the B-log from the original database can be analyzed in our own queues. With the same way, we could provide the data to the databases, and we also have the application of subscription, and we also have checking capabilities. And you could check whether there is a structuralized data in the queues, and you can identify the correctness of those data. So in those scenarios, we could support multiple data sources and categories. Here I have raised an example of the scenarios, such as the Lomsenko and subscription, as well as the big data. So all of these scenarios can be supported through the data migration and subscription. Now I'd like to share with you some of the cases. The first case is one of our clients who have been using the cloud services. They want to achieve the offsite active function, and they wanted to do it by themselves because all of the internet companies are very innovative. So they want to try it by themselves, but after some time they realized that it was too difficult. So they wanted to resort to the Ali Cloud architect, and in this process we can directly provide them with a lot of cloud-based services. And in this process, they can very directly construct a dual direction synchronization function, and by doing so, they can very easily achieve this offsite active function. And the second case is of a bank, and it wants to provide a remote service, and required by People's Bank in China, we have to promote those remote services. And this is a win-win situation. And they want Ali to provide support for the remote active services. And we have the RDC ABC, but how to do it? And the parts of the traffic is written in ADC-A, and part of it is written in IDC-B in Hangzhou. So if the local IDC-A or B has a problem, then we can switch part of the traffic into IDC-C in Shenzhen, and currently the latency can be controlled within a second. So suppose the IDC has a situation, and if IDC-A is failed, then we could have a host and a backup switch. It means that we can directly transfer the traffic into IDC-B. So for the clients, this can happen within a second. And the second situation is that both IDC-A and B are failed. So Hangzhou is down, and now we have used DTS to transmit the data, and we could back up the data in another region. So we can directly shift the traffic from AB to C in Shenzhen. And another case is also very typical. They want to transfer the Oracle database. In this process, we have realized that the first thing you need to transfer is the MISC. And from Oracle to DRS, from Oracle to Oracle. In this process, we need to first generate a very small point, and gradually we need to roll it up. So from Oracle to MySQL in a large shopping mall, it is a very large using scenario, and we have developed some functions for this client. So Oracle to DRS, from Oracle to RDS, from Oracle to Oracle, we can realize a dual direction synchronization of the data, and it is under development, and we need to check it in a Double 11 shopping festival this year. The last case I'd like to share with you is a game client. So this is a Sino-American synchronization scenario. We have developed a lot of successful game products, and some of the clients want to develop the games in the States. So we want to have a synchronized data between China and America. So this is a dual direction transfer, but there is a problem of latency. The client requires us to control the latency within a second. For example, if the customer wants to strike an order or to make a payment, then we want to control the latency within a second. And that's all for my presentation. Thank you very much for your patience.